Let's go ahead and answer question B. How much is it going to cost the economy to change the production mix? And we can answer this question by taking a look at the opportunity cost. The cost of a good in terms of another that must be given up. And if you remember from chapter number 1, it's also the next best alternative. So there are a few things that we want to note about the opportunity cost. First, the opportunity cost is always going to be in terms of the other good. So this is one of the reasons why we work with only 2 goods. If we want to produce more backpacks, we have to give up on the production of tablets. If we want to produce more tablets, we have to give up on the production of backpacks. So it's always going to be set in terms of the other good, something that you should keep in the back of your mind as we do some of these calculations. So if we want to produce more of good A, we have to give up some of good B. If we want to produce more of good B, we have to give up on the production of good A. So the next best alternative is going to be the alternative good or the other good. The second thing that we want to know is to go ahead and use the numbers that are being given or provided to us. You do not want to go ahead and try to sort of interpolate or extrapolate what the numbers are in between these numbers that you see right here. Always use the numbers that are being provided to you. So 12, 10, 8, 6, 4, 2, 0, 0, 1, 2, 3, 4, 5, 6. Only use the numbers that are being provided to you. If you try to assume what the numbers are in between here, that can quickly lead you down an incorrect path. So that's not something that you want to do, especially with exam questions. So let's go ahead and find the opportunity cost of a tablet first. So we can go ahead and use the numbers that are being provided to us. And because we are only working with 2 goods, we immediately know that the opportunity cost of producing more tablets is going to be us giving up on the production of some backpacks. So here, use the numbers. Easiest one to go ahead and take a look at is the first row right here. We have 12,000 backpacks, 0 tablets. So in order for us to produce 1 additional tablet, how many backpacks are we giving up on the production of? We're giving up on the production of 12 minus 10. We're giving up on the production of 2,000 backpacks. And that's exactly the opportunity cost right here. So simply starting us off, the opportunity cost of producing 1 tablet, producing 1 additional tablet, so additional 1,000 tablets, is 2 backpacks. 2 backpacks. So here, in order for us to produce 1 additional tablet, we have to give up on the production of 2 backpacks. So therefore, the opportunity cost of 1 tablet is 2 backpacks. So here, this is exactly where the opportunity cost of good A is going to be set in terms of good B. But we can make this a little bit more complex. We just don't have to go from the first row to the second row. We can go, say, from the first row all the way to the 4th row to the 5th row. We just have to specify where our initial point is and where our ending point is. So suppose that we want to go ahead and produce 3 additional tablets. So opportunity cost of producing 3 tablets. So we want to go ahead and produce 3 additional tablets rather than the 1 additional tablet. So we go from this first row right here, we have 0 tablets, 3 additional tablets, 1, 2, 3. So as we go from this first row all the way down to the 4th row right here, how many backpacks are we giving up on the production of? Initially, we had 12 backpacks. Now we have only 6 backpacks. So therefore, we're giving up on the production of 6 backpacks. Opportunity cost of producing 3 tablets is 6 backpacks. And one thing what we like to do in terms of opportunity cost is we like to sort of normalize the good that we're taking a look at to 1. That just gives us a good interpretation. So how do we convert these 3 tablets into 1 tablet? We don't want to find the opportunity cost of 3 tablets. We just want to find the opportunity cost of 1 tablet. So how do you think we're going to go ahead and do that? One thing that we can go ahead and do is just use a little bit of an algebraic sort of manipulation right here. What you do to one side, you can go ahead and do to the other. We're going to go ahead and divide this by 3. So divide it by the number that you see right here on both sides in order to normalize it to get it to 1 tablet so we can get some type of workable interpretation from that. And when we go ahead and do this, we go ahead and simplify. We can say that the opportunity cost, the OC right here, of 1 tablet, so 3 divided by 3 gives us 1. It's going to be 6 divided by 3 backpacks, which is 2 backpacks. 2 backpacks. So here we notice that, hey, we have the same exact opportunity cost as before. The opportunity cost of 1 tablet, of producing 1 tablet, was 2 backpacks. And the same right here, the opportunity cost of producing 3 additional tablets is 6 backpacks. Once we go ahead and simplify that down, we get 1 tablet we're giving up on the production of 2 backpacks. So this is going to be something unusual that we see right here, where we have the same exact ratio for our opportunity cost. And why do you think this is going to be the same exact ratio? Why do we get the same exact numbers right here for our opportunity cost? The reason why this is going to be true is because we have a linear PPF. So when we take a look at this problem right here, we have a linear PPF. So we're just using the same numbers that were given in the previous sort of slides right here, and we have a straight line. We go from one axis all the way to the next axis. There's no curves, no nothing. So this is where we have a linear PPF. Anytime we have a linear PPF, our opportunity cost will always be the same or constant. They'll never change. So opportunity cost will be constant because the PPF is linear. Because PPF is linear. So constant, meaning that we have the same ratio, it's never going to change, and that's only going to be because our PPF is linear, it is a straight line. So it doesn't really matter where we take our sort of ratio from. It can be from the first row to the second row. It can be from the third row to the fourth row to the sixth row, the first row all the way to the seventh row. It doesn't really matter because we'll always get the same exact ratio because our PPF is seen as linear. One thing that we can also do as well is not only can we find the opportunity cost of good A, we can also find the opportunity cost of good B. We just need to go ahead and work in the opposite direction. So let's go ahead and do that. Let's find the opportunity cost of producing one additional backpack. So opportunity cost of producing one additional backpack. One additional backpack. So with this, we need to go ahead and use the numbers that are being provided to us in this table. We see as we go from the bottom half of this table right now, we have 0 backpacks to 2 backpacks, so we don't necessarily have a 1 backpack right here. So we just want to go ahead and use the numbers that are being provided to us. Try not to assume what's in between right here, because that can lead you down a quickly lead you down an incorrect path, as we've already mentioned. So what we can do is we can say, what's the opportunity cost of producing 2 additional backpacks? How many tablets are we giving up on the production of? We go from 6 tablets to 5 tablets, so we're giving up on the production of 1 tablet right here. So the difference between these two numbers. So using the numbers that we see on that table right there, to produce 2 additional backpacks, we gave up on 1 tablet. We give up 1 tablet. But remember, anytime we want to go ahead and use the opportunity cost, we want to normalize the good that we want to find the opportunity cost for. So how do we get rid of this 2 right here? What do we need to do? We need to go ahead and divide 2 on both sides. And once we do that, we can go ahead and simplify. That just tells us that the opportunity cost of 1 backpack, in order for us to produce 1 additional backpack, what do we give up on the production of? We give up half a tablet. So is 1/2 a tablet. So in order for us to produce 1 additional backpack, we have to give up on the production of 1/2 a tablet. And once again, the opportunity cost is always set in terms of the other good. The opportunity cost of 1 backpack is a 1/2 a tablet in this instance. So it's a little bit trivial in this type of sense to do the opportunity cost. It's sort of easy because we are taking a look at a linear PPF, but I do want to go ahead and provide you with an equation that will be very, very handy for our next sort of section right here. So anytime we want to find the opportunity cost, we can use the equation for the opportunity cost, And that's going to be what you give up over what you gain. So what you give up divided by what you gain. And this is going to give us the opportunity cost of the good that's in the denominator. So opportunity cost of the denominator good. And we can use this formula right here to do it to sort of see exactly what happens with our linear PPF. So if we want to find the opportunity cost of 2 additional backpacks, we put the 2 backpacks on the bottom right here. What do we gain? We gained these 2 additional backpacks, and what did we give up? We gave up the production of 1 tablet, so 1/2, that gives us 1/2 of the denominator good, which is the backpacks on the bottom. So in order for us to produce one additional backpack, we give up 1/2 of a tablet. So this is essentially what you do in all these instances. We can do the opportunity cost of producing a tablet as well. So in order to produce one additional tablet, we gave up on the production of 2 backpacks, but we gained 1 tablet. So therefore, the opportunity cost of producing 1 tablet is 2 backpacks. So nothing new in that type of regard with this. This equation right here, as we said, is going to become very, very important as we work through more complex versions of the opportunity cost as we move throughout the rest of the chapter. And one thing that we do want to note as well is the reason why we have a linear PPF in this particular example is because we assume that all of our factors of production were substitutable for one another. So land, labor, physical capital, and technology, we see them as all the same to one another. They're essentially identical. However, this is going to be a little bit of a not non-realistic assumption in this sort of case. So we want to make our PPF model, our opportunity cost measurements, just a little bit more complex, a little bit more realistic, and we'll see exactly how our PPF is going to change once we assume that away. I'll see you guys there.